Okay, so let's see. Are we live? Hello, 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 hello. Hello, 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 hello. Welcome. Howdy. So, we're going to get into yet another problem. And it's going to be top K frequent elements. Let's give it a shot. Let's get into it. Let's take a look. Should be going to bed now. However, I kind of wanted to look at this problem. That last problem was pretty interesting. I couldn't figure out I didn't figure out I was curious about exponentiation and how to compute exponentiation, and I couldn't figure out a way to compute what I was looking for faster. So yeah, I ended up with a logarithmic time solution. For that problem, you could actually make a static, I guess, solution that's very efficient, I suppose. Excuse me. It's slightly more efficient than logarithmic if you have a lot of calls. Excuse me, but yeah. Anyway, yeah, using the power function is better than trying to write your own. Basically, you would do powers by squaring, and then that's its own algorithm. So anyway, kind of got hung up on that. I was looking at that for a while. Given a non-empty array of integers, return the k most frequent elements. All right. So this is going to be an interesting one. May assume k is always valid. Algorithm's time complexity must be better than n log n, where n is the array size. It's guaranteed that the answer is unique. In other words, the set of top k frequent elements is unique. Return the answer in any order. Yeah, so I mean, I don't know. They didn't give us any space requirements, so let's go with that. We have a frequency map. Actually, yeah, I could do this. Better than O of n log n, n is the array size. If there are ties, what do you get? Oh. Curious about what they want for the answers. I don't know. Well, this is going to be n log n time. We can do it better than log n. We can use a heap instead of sorting. That'll give us k log k. O of n plus k log k. However, that's not going to be. I mean, that worst case it would be n log n, right? If k is size of n. I don't know, man. I don't know. If we sort this frequency map, and then or just, you know what we could do? This probably makes more sense. Yeah. Well, no. I don't know. Nah. I don't know. Kind of just messing around with different things here. Something like this. Something like this. Oh. I don't think you can sort this. Yeah, I don't think you can sort it. You could do something similar though. Make a set of pairs. You have M, I think, is the comparator. Could try something like this. See if that compiles. I don't know if that works. I don't think so. How do we... Give me a moment here. Compare. Key, compare. I think you have to make a class out of this. Something like this. entirely sure where that came from. So binary operator has 3. Okay. Oh no. I just okay. I don't know, man. So confused. How do you even? What is this? Okay, got it. That's the most confusing thing. What is even going on here? What? Oh, please. Const expression, bool, const. Const, everything const. That's all we need. Can we make that const? Oh man. Oh, okay. Interesting. So this is how you write a comparator function. So anyway, so we S, and now we take ret. Oh boy. Oh no. Please. What is going on? What is this? Oh, I know why. No, it's just... Okay. I think I know what the problem is. All right. It's wrong. Wait, what? Wait, what? What? What happened? 2 and 3. 1 and 2. Oh, we're supposed to go the other direction. Still, what's going on? Oh, it's a multi-set. Okay. Let's see if we can run this algorithm. Alright. Oh wow, it's pretty efficient, huh? So, a few things to say about this. Oh boy. This is like the sort of simplest brute force approach, naive approach, not a naive approach, but like this is sort of like the simplest approach that I can think of. Excuse me, it still took 15 minutes. So, the idea is pretty straightforward. We create a frequency map, just count all the numbers. It doesn't say anything about the space complexity, so that's great. Count all the numbers, and then we say, okay, once we've counted all of our numbers, we're going to take all of these pairs that are in this frequency map, and we're going to dump them into a multi-set, and we're going to use a custom comparator. So basically our multi-set will be sorted backwards, and we're going to have allow duplicate keys, and in the multi-set we're going to have the pairs from the frequency map, and we're going to put the numbers in this multi-set using that comparator such that we're comparing the second element of each pair, so the frequency. So basically what the multi-set's going to be is a sorted set of pairs of elements sorted by the second, what do they call that? Sorted by the second element of the pair, which is going to be the frequencies. And then we're going to iterate over the set of the multi-set, and we're going to grab the first elements. So we're going to iterate over the first k pairs in that sorted multi-set that's sorted by the frequencies, and then we're going to grab the values associated with those pairs and dump that into the return vector. So we push everything into a frequency map, then push those pairs into basically a sorting mechanism, and then we pull the k elements that we want out of that sorting mechanism. Now, alternatively, we could basically create a vector. In order to sort this in a different way, we can create a vector of the pairs, and then create a heap out of that vector based on the pairs. And the heap, the sorting algorithm for the heap, the sorting, I guess, what do you want to call that? The sorting function for the heap would be the same. It's basically the pairs sorted by the second values, and then we could pop from the top of the heap. We could pop the first k elements that we want. Creating a heap is linear time, and then popping from the heap it's O of k log k, where k is the number of times we pop from the heap. So if we could make this a little bit more efficient doing that, using a heap instead of a multi-set. So the issue with the multi-set is that this actually would, technically, if every element has a frequency of only 1, then this multi-set ends up being n log n time to create in the worst case. Although anytime that the frequency has any kind of duplicates, and anytime you have a duplicate, this will be better than n log n. Or it's still technically n log n. However, it would be better in those cases. It would be slightly better. Even if we use the heap and pop from the heap, we still have k log k. In the worst case, becomes n log n, where k is equal to n. So I'm not really sure how to, I'm not sure if it matters if we use the multiset this way or if we use a heap, because we're still going to have k log k, which k could be equal to n, and then we're n log n, and then we're wondering, how is this even possible? We could technically use counting sort on the frequencies because the frequencies are bounded by n. However, that would give us something better than n log n. And then pull the k elements that we want. The problem with that, though, is that n could be very, very large, I guess. And counting sort's kind of awkward if n's very large. It's actually bounded by the largest frequency. Counting sort. Which is kind of interesting because if the frequency, you could basically choose between counting sort and using a multiset, I guess, or using a heap if you wanted to. That would guarantee better than n log n time. You could say basically if your frequency is, whatever the mode of the frequency is, if your frequency is n over 2, the highest frequency is n over 2, then you could just use a heap. No, well, that still gives you k log k, which is n over 2 log n over 2, which is sort of n log n. I don't know. I guess you would always just want to use counting sort then to sort these pairs. And what would end up happening is dump the pairs into a vector, and then dump the pairs into a vector, and then sort, and then pull the first k elements you need. You could even do quick select actually on the first k elements. But actually, if k is n, that gives you O of n squared time, which is kind of interesting. Oh, you don't need to do any kind of sorting. Oh, I didn't think of that. Oh, that's awesome. That's really interesting. All right, you ready for this? Oh, okay. I know what to do. Let's dump everything into a vector. Oh, that's really nifty. We can use these can be we can do O of n time. That's really interesting. You can do better. Let's call this V. Oh, you can do better than that. Oh, I didn't realize that. Okay, that's interesting. So now what we're going to do is we're going to use nth element. Yeah, there we go. We can use quick select. And we can use a compare function. There we go. That's what we want. That's what we want. And this we could make this our lambda again. Doesn't need to be a, well, we could just, yeah. Anyway, what does the compare do? Comp. Binary comparison function comp. I think we can, I'll figure it out. So, let's do it this way. Auto it equals v dot begin plus k, standard nth element of v dot begin it and v dot end, and this comparator we can rewrite this to auto m equals something like so. And we could probably move these back now. And now it's going to be v dot begin plus k. How about them apples? Or to it. Expect body of lambda expression. What's going on here? Pair A, B, frequency, begin, end. Can we just find out what's wrong? Let's see. What about these two? Does this work? Okay, it does. Okay, that works. And so it really is this, just this part here. Oh, that's why. Yeah, I see. Oh, I missed that. So now we have to extract the first elements from V. Yeah. Excuse me. We can do conversion operator, I think, right? We could do constructor. Or transform is really what we want to do. Okay, interesting. Something like this. That's what we want. Unary operator. Last, first. Yeah, something like this. So let's say red. And we just do standard transform of v.begin it, and the operator is going to be, it's going to be red.begin, and we're going to do this guy. Const standard pair ints. Just call this Q, I don't know. We'll say X doesn't give us a Boolean, give us an integer, turn X dot second, or first. Something of this nature. Runtime, null pointer. There we go. Is that correct? Hey, that's better. Same runtime, but a little less memory. Now, this is quite different from what we had before. Yeah, this is quite different from what we had before. And now this is indeed better than nlog n. And the reason is it takes linear time to dump to create the frequency map. It takes, oh, I don't think we need this anymore, this M. Oh, we do. Yeah, we do. It takes linear time to dump that into a vector of pairs. It takes linear time to partition those pairs based off of the frequencies. And then it takes linear time with respect to k, which is less than n, to place those, transform those pairs, strip them of the first value, basically take the pairs, the first k pairs, and move them into an integer vector and strip away the frequency so it's only, and take only the first values, and to take only the first part of the pair, and then return that vector at the end. Yeah, it's linear space and linear time, the whole thing, all the way across. Oh, that feels good. That feels so good. And I used all of their built-in routines for this too, which is awesome. So yeah, this is pretty neat. I really like this solution. I like this approach. It's super efficient like that. Almost 100%. Uses kind of a good chunk of memory though, because of the amount of like kind of moving things in between. But yeah, look at that, we almost have that optimal memory too. So we did alright. We did okay. Let's see if we can randomly hit 100%. We'll try a couple more times. So this is a really interesting question. I like this a lot. I feel like a genius now, having solved it. Smarty pants. Try one more time. Okay, yeah, that's enough. But we did good. We did alright. Sweet. Yeah, that's interesting question, man. Interesting question. I'm glad we went through it. Not much to say here other than sort of a step-by-step thing that we did. All right, we're at 36 minutes. That's a pretty good amount of time. I don't think I have really much more to say. I mean, we got it. You know, that's kind of all there's to say. And yeah, awesome. That feels good, man. It's a good feeling. So yeah, thank you all for watching. Talk to you soon. Have a good rest of your day. Hope you found this interesting or entertaining. There's some variation of that. And yeah, have a good rest of your night. Take care.